Alright, so this is the second tutorial for the Arduino. Um, I wish I could show you some of this in real life, but I don't have an Arduino, so we're going to do all of this on simulation on Tinkercad. This software works pretty well for beginner level learning, so I think this should work well for the tutorials that I'm going to be doing. So you see, we're going to bring in another component. This is called a breadboard. So a breadboard is an extension that's used for the Arduino because it's really hard to connect components straight to the nodes on the Arduino. So if you put it on this breadboard, it's easier to organize. So let's go over the basic structure of this board. So as you can see, you have plus. The first thing that you can notice is that there's a plus and a minus. In these columns, you attach power and ground. So plus is the anode or power. So the first connection you usually make in Arduino is from 5 volts to the power line. So you also always want to color code your wires. So this red wire signifies that it's a power wire. So now you're going to see all these green dots. All these green dots, they're going to be connected by a metal plate underneath. So all the power, as you're rerouting the power from 5 volts, it's coming through this wire, and now it's going to send electricity through a whole metal plate under this board containing all of these nodes. So now we can take power from one of these nodes and we can transmit it to another port, to another node on the breadboard. Say we connect it to here. Let's keep it red because it's still on the power side. So now you can see all these green arrows are powered up when they're so the metal plates under these are connected vertically. So all the nodes here now have electricity running through them. So say you attach a component. Let's pick LED. This is one of the most basic components. Make sure you'll see in Arduino that it's labeled anode and cathode, but in real life, an LED, the longer side will be the anode and the shorter side will be the cathode. So you want to attach the anode to the side coming from power, and then you want to lead power out from the side that says cathode. So basically the circuit right now is power coming from 5 volts going to the power line, line on the breadboard, then being transmitted to 5A, and then it's going to the LED, going through the LED from the anode to the cathode, and it's going to come around, and now we're going to connect it back to the ground line, and we're going to make this black because that's just convention, and from the ground line on the breadboard back to ground on the Arduino. You're going to see, also remember to color code this brown. So you're going to see this is a complete circuit. We started at power and we ended up ground. That's usually a good thing. That means your circuit is complete as long as you didn't mess something up on the process. And now if we start the simulation, what we'll see is this error. So what it's saying basically is the amperage that's going through the LED is way too high. What's going through the LED right now is 483 milliamps, while the absolute maximum for it is 20 milliamps. So let's take this wire out and put in a resistor. What a resistor does is slow down the flow of electrons. So you can think of it as like a worse conductor. Instead of having, probably these are iron wires because that conducts electricity pretty well. This would have some sort of blockage in that, and this would allow for electrons to move more slow with less force through the LED, making it more manageable for the circuitry inside the LED to provide light without burning out. So now we're going to see, I just picked a random LED. I think this is the correct one. And if we start the simulation, you can see that it's running power through, giving no error. This should be the right amount of amperage for the LED. So this is the most basic type of circuit in Arduino, and I think up to now it's still pretty much review for you. So now we can go into some more complicated designs in Arduino. So let's delete this current circuitry. So now if you want to do some fun stuff with the LED, we're going to need to control it. So how we're going to control an LED is with one of these digital pins that I talked to before. So these can send a varying signal, right? If we're getting straight power from the 5 volts, we're not able to control the LED. But if we can change the amount of voltage being sent to the LED, we can do something with it. So we'll take the port 4 and we'll connect it to the anode, and this is gonna run power. Remember, this is gonna run power through this whole vertical strip here, and that includes the anode of the LED. So now we have power going to the LED, and we're not connecting it from 5 volts because the digital pins also send out a signal. And we're gonna put a resistor down, bringing it back to ground, which is still necessary because we still haven't completed the circuit. And we will connect this back to ground and make sure to make this black, and green is fine for digital pins. So now we have a basic circuit for controlling an LED. Now what we have to do is we have to code this. So let's go to the text version. So you're going to see in Arduino code, there are 2 main methods, setup and loop. So in the setup method, you're going to initialize all the components you need, and you'll see this function pin mode. What it basically does is this first argument for pin mode tells you which pin number you're using, and the second argument tells you what you're going to be using for, whether sending a signal output or taking a signal input. So here we use the 4 pins, so let's set this to 4, pin mode 4, and let's just use the code that's already set up here and see what it does. So we have digital write, 4 high, digital write 4 low. So let's see what this does, and we'll talk about the code in a second. So as you can see, the LED starts blinking. So now let's discuss a little bit about the code. Digital write means you're sending a signal from a digital pin, so that's what the write comes from. So in this function takes 2 arguments. First, the pin number that you're sending it from, and then what the value is. In digital write, you can only send a high or a low. If you try to send a number, if the number is not 0, it's always going to send a full value. So we have digital 4 and high, so we're going to send a high signal continuously. This is in loop, it will continuously do whatever's there. So we're going to continuously send a high signal, then we're going to wait for, we're going to continuously send that for 1,000 milliseconds, which is a second, and then we're going to send a low signal, which is 0, not sending any voltage. And then there's going to be another delay of 1 second, and then it's going to turn on again. So as you can see, that creates the blinking mechanism on the LED. So now that we've gone over digital pins, we can do some more fancy stuff with this code, but I think you understand the coding aspect. I want to focus more on the electrical aspect. So we use an LED, right? But this basic concept opens up a lot of doors for electronics. Now that we have the power to control components, we can extend this to a variety of different components. So let's take, what should we take? Let's take an LED RGB. So this is a little more complicated. As you can see, there are 4 nodes instead of 2. And what this RGB LED can do for you is that instead of simply sending instead of simply creating one color light, it can create several different colors by combining green, blue, red, your RGB colors. So we're gonna take, instead of only taking 1 digital signal, we're gonna send 3 digital signals. Let's set it up as 3, 4, and 5. So these are all going to be sending different voltages. these can all control the voltages sent to each of the RGB nodes. So I'm just gonna clean up the wires here real quick, and now we can write a quick code for this program. So in the setup, we're gonna need to set up more than just one pin. We don't only have 4 now. We have to set up 4, 5, and 6. We got 4, 5, and 6, and they're both they're all used as outputs. So if we want to write some fun code for this RGB LED, and we want it to blink red, then blink blue, then blink green, let's do something like this. So we will digital write high to the 4 pin, which is blue. Then we'll wait for, let's make the blinking a little faster. Let's make 100 milliseconds. Then we got digital write, and we'll write to 5 high, and then we'll write high to 6, and make sure you have to write low to each of these to turn them off too, if you want to make them blink different colors. So that's gonna make it low, and now we can just copy this code and copy this. So let's start the simulation and see what happens. So as you can see, it's kind of blinking. It's blinking a little fast, so let's change it to make it a little more appealing. Now you can see it's going from red to blue to, oops, forgot to change that. 4 low, 5 low, oops, 5 low, and 5 low. Oh. Now if you start simulation, we can get what we wanted. Oh, whoops, it's 3. Let me change that real quick. So 3 wasn't 4, 5, 6, it was that. Here we go. Oh my god. Alright, now it's doing what we want it to do. It's blinking different colors. And I forgot to write 3 low. It's okay, you get the idea. So that's basic controls. Now we went over digital pins. That's the end of this video. Next video we'll talk about analog inputs and outputs.